In a dusty corner of Texas, a cathedral of manufacturing has risen. This is the Starfactory.
The goal? To build one massive rocket every single day. The destination? Mars.
Welcome inside the most advanced rocket production facility on Earth.
It starts here, not with carbon fiber, but with 304L stainless steel. Heavy, cheap, and strong.
Rolls of steel are uncoiled and laser cut with sub-millimeter precision. Giant rollers bend the cold steel into rings. Each ring is 9 meters in diameter.
Automated robots stitch the ends together. This vertical weld must hold against the pressure of deep space.
Inside, stringers are welded to prevent the hull from crumpling like a soda can under thrust.
The rings are stacked in groups of 3 or 4, creating barrel sections.
Enter the automated welding stations. These machines work 24/7, fusing the sections together.
Bulkheads. These domes separate the fuel tanks. Shaping them requires immense pressure.
All right, slow rotation to the left, keep it steady.
Copy that, rotating left.
Watch the clearance on the east side.
The downcomer.
The common dome is a critical single barrier separating freezing oxygen from volatile methane. The Starfactory replaces the old tents with a permanent, weatherproof assembly line.
The nose cone. Its complex compound curves are the hardest part to manufacture.
Robots place the tiles on pins, but the complex curves still require human finesse.
Forward and aft flaps. These are not wings. They are skydiver limbs for steering in the atmosphere. Powered by massive battery packs and Tesla motors, they exert tons of torque in milliseconds. The Mega Bay, a skyscraper built just to house other skyscrapers. Massive overhead cranes perform the final stacking, mating the nose to the fuel tanks. The final circumferential weld is critical. It turns 2 halves into one Starship. Meanwhile, the Super Heavy booster is assembled, the largest rocket stage ever built. The grid fins. Unlike Falcon 9's titanium, these are welded steel, designed to catch the booster in midair. The heart of the beast, the Raptor engine, mass-produced like cars, not rockets.
A full-flow staged combustion cycle engine. Insanely complex, yet built to be reusable. 33 engines are mounted to the booster's puck. The plumbing nightmare is a work of art.
The outer ring of engines is fixed, but the inner engines gimbal to steer the rocket.
To move this 20-story building, SpaceX uses SPMTs, massive multi-wheeled crawlers.
Rollout. The booster leaves the factory and heads down Highway 4 to the launch site.
Okay, get closer.
Is this angle good? It's unbelievable.
Arrival at Stage 0. The launch pad is as complex as the rocket itself.
The chopstick's arms aren't just for catching. They stack the rocket, eliminating the need for a crane.
It rests on the orbital launch mount, surrounded by shielding to protect against the fury of 33 engines.
Next comes the ship, the upper stage that will make the journey to orbit. Full stack. At 120 meters, it is the tallest and most powerful flying object ever built.
The quick disconnect arm fuels the ship and stabilizes it until the moment of liftoff.
Before fire, there is ice. Cryogenic proof testing loads the tanks with liquid nitrogen to test weld integrity.
The super-chilled propellant shrinks the steel, hardening the tank for flight pressures.
All personnel must evacuate the launch complex immediately.
To save the pad, a massive water deluge system shoots tons of water upward to counteract the engine plume.
33 Raptors ignite. The shock wave is registered on seismographs miles away.
Engineers analyze terabytes of data. Pressures, temperatures, vibrations. Every millisecond counts.
After the fire, the factory team rushes back in, inspecting tiles, engines, and concrete for damage.
For Starlink missions, the payload door, dubbed the PEZ dispenser, must work perfectly in the vacuum of space.
The factory itself is a prototype, constantly expanding, evolving, and eating up the old production tents.
Just-in-time logistics keeps thousands of unique parts flowing to the assembly stations.
The tank farm stores the millions of pounds of methane and oxygen needed for a single launch.
Minus 10 seconds. The factory goes silent. The world watches.
Liftoff. 5,000 tons of steel and fuel defy gravity.
Clearing the tower. The Starfactory's product is now in its element.
Hot staging. A violent ballet where the upper stage blasts the booster away.
But for the booster, the mission is only half over. It must return to the factory that built it.
The catch. Catching a building out of the sky with chopsticks. The holy grail of reusability.
Half a world away, the ship faces the ultimate test. Reentry plasma hotter than the sun.
The belly flop maneuver, using the atmosphere to brake, then flipping vertical for landing.
Not every ship makes it. The boneyard is a reminder that failure is the fastest teacher.
At Starbase, even failure is recycled. Scrap steel is sent back to be melted down.
The lights never turn off at Starbase. 3 shifts, 24 hours a day.
The techniques learned here are not just for Earth. They are the blueprints for industry on Mars. Musk's vision isn't just one ship. It's a fleet, a factory churning out 1,000 ships.
Perfection in every weld. Because in space, a pinhole leak is fatal.
Keep an eye on the stabilization fins during the next phase.
Roger that. We'll run the diagnostics again.
Rows of domes wait for their turn in the stack, looking like a fleet of parked UFOs. Below the pad, a labyrinth of tunnels keeps the propellant flowing.
Crane operators here have the highest stakes job in the world.
The vacuum Raptor. Its nozzle is sized to expand gas in the void of space.
Tiles are baked at extreme temperatures to ensure they won't crack upon re-entry.
Robot dogs patrol the hazardous areas where humans can't go.
Visual inspection is constant. Every bolt, every seam, every tile.
We need to double check the alignment right here on the upper stage.
Understood. I'll have the team verify the sensors immediately.
As the sun sets over the Rio Grande, the silhouette of the future stands tall.
Neither rain nor heat slows the progress. The timeline is ASAP. The ride up the tower offers a view of the factory that built the beast.
Inside the empty tanks, the scale feels religious. A cathedral of stainless steel.
The sheer size of the components is hard to comprehend until you stand next to them.
Before metal is cut, physics is tested in the digital realm. The factory grows as fast as the rockets. Thousands of yards of concrete.
Shift change. One army leaves, another arrive to take up the torch.
And now, the model is being cloned. A second factory rises at Cape Canaveral. Taller than the Saturn V. More thrust than the N1. A new king of the skies.
Goal? Make it cheap. Steel is dollars per pound, not thousands like carbon fiber. Iterative design. Build, test, fly, crash, learn, repeat.
Go and give it 2 more clicks. It's locked in. Stand clear.
Standing beneath it, you feel the potential energy waiting to be unleashed. The Starfactory isn't just building rockets. It's building the bridge to a multi-planetary species.
It is the most ambitious manufacturing project in human history. Built by human hands to carry human dreams.
This inside the Starfactory.
Ad Astra.